Hello everyone, good evening. So here we shall start from question number 28 onwards. So here it is told to prove that the line joining the midpoints of the diagonals of a trapezium is parallel to the parallel sides of the trapezium. So we can draw one trapezium. So this is the trapezium which is CD, and AB is parallel to DC. We will join the midpoints of the diagonals. So the midpoint of AC is E and the midpoint of DB is F. We have to show that EF is parallel to the parallel sides. So it is given that E and F are respectively the midpoints. E and F are respectively the midpoints of the diagonals AC and BD, AC and DB, AC and DB in the trapezium, ABCD, where AB is parallel to CD, and obviously AD and BC are the non-parallel sides. AD and BC are the non-parallel sides. So we have to prove that the line segment EF is parallel to AB, which is also parallel to DC. This is what to prove. So how to prove? We can join CF and then extend to meet AB at the point T, suppose. So we have to draw one construction. Construction is CF is drawn, line segment CF is drawn and extended to intersect the line AB at the point P. Then we have to prove it. So the proof, write the proof like this. First we have to take the triangle DCF and triangle PBF. Now in triangle DCF and triangle PBF, you can see that angle PDF, that is equal to angle PBF, since alternate interior angles are equal, as it is given that DC is parallel to AB. And also angle CFD is equal to angle BFP. Since why? Since vertically opposite angles are equal. The vertically opposite angles are equal. And DF equals to BF. And BF equals to BF. BF equals to BF since it is given that F is the midpoint of DB. F is the midpoint of DB. So therefore we can say that that triangle DCF is congruent to triangle PDF. So here we have taken two angles, these two angles and the included side. So therefore I can say by angle side angle, by ASA rule of congruency, these two triangles are congruent. So therefore we can say that CF equals to FP, CF equals to PF, CF equals to PF by CTCT. So hence we can now see that hence in triangle CAP, E is the midpoint of AC. E is the midpoint of AC. This given. And similarly, F is the midpoint of CP. F is the midpoint of CP. Since CF is equal to PF, which is proved earlier, or I can say proved above, proved earlier or proved above, proved above. Proved above. Proved above. F is the midpoint of CP, which is proved above. The midpoint of CP, which is proved above. So therefore we can say that therefore EF is parallel to AP. EF is parallel to AP by using the midpoint theorem. By using midpoint theorem. So hence we can say that EF will be parallel to AB also. EF will be parallel to AB, which is again parallel to CD. So hence proved. Then in question number 29, it is told that P is the midpoint of side CD of parallelogram ABCD. ABCD. P is the midpoint of CD, and a line through C parallel to PA. Line through C parallel to PA intersects AB at Q. Intersects AB at Q, and DA produced at R. dA produced at R. So we have to prove that dA equals to AR, CQ is equal to QR. So it is given that P is the midpoint. P is the midpoint of the side CD. P is the midpoint of the side CD of a parallelogram ABCD. Parallelogram ABCD. Then a line through the point C. A line through C parallel to PA. Parallel to PA intersects. Parallel to PA intersects AB at Q. Intersects AB at Q. And dA produced at R. dA produced at R. And we have to prove that dA equals to AR, dA equals to AR, and CQ is equal to QR. CQ equals to QR. That we have to prove. So then the proof is like this. So here we can see that quadrilateral quadrilateral AQCP. AQ is parallel to CP. AQ is parallel to CP since AB is parallel to DC, which is given, and AP is parallel to QC. AP is parallel to QC, which is also given. So therefore, I can say that AQCP is a parallelogram since it's both pair of opposite sides are parallel. Since it's both pair of opposite sides, are parallel to each other. Parallel to each other. So I can say that. Okay. Now, therefore we can see that CP equals to AQ. CP equals to AQ. Since the opposite sides of a parallelogram are equal, CP equals to AQ and also AP equals to CQ. Since the reasoning, since the opposite sides of a parallelogram are equal. Also we can say that angle PAQ that is equal to angle PCQ. Since the opposite angles of a parallelogram are equal, the opposite angles of a parallelogram are equal. And we can see that angle PCQ that is equal to angle BQC. Angle BQC BCQ is equal to BQC since alternate interangles are equal. Since alternate interangles are equal, as AB is parallel to BC and CQ is the conversion. So now here also you can see that in triangle DRC P is the midpoint. P is the midpoint of DC. P is the midpoint of DC, and which is given, and also PA is parallel to CQ, and PA is parallel to CQ, or I can say PA is parallel to CR, which is also given. So therefore, I can say that A is also the midpoint of DR. Therefore, A is also the midpoint. Is also the midpoint of DR by using the converse of midpoint theorem. Using the converse of midpoint theorem. Converse of midpoint theorem. So therefore, I can say that BA is equal to AR. BA is equal to AR. So hence proved part 1. Part 1 has been proved. So first part is TA is equal to AR, and second part is CQ is equal to QR, that also we have to prove. And then now we can see that in triangle AQR, and triangle BQC, angle AQR is equal to angle BQC, angle AQR is equal to angle BQC. Since they are vertically opposite angles are equal, these vertically opposite angles are equal. Vertically opposite angles are equal, and angle ARQ, angle ARQ is equal to angle angle BCQ, angle BCQ. ARQ is equal to BCQ. Since alternate interior angles are equal, since alternate interior angles are equal, as DR is parallel to DC. DR is parallel to DC, and obviously AB is the, or I can say RC is the transversal. So we have shown these two angles are equal and these two angles are equal, and we can say that since DA is equal to AR, DA is equal to AR, we have proved, and also we can say that, and also DA is equal to BC. DA is equal to BC. Since the DA is equal to BC, since opposite sides of a parallelogram are equal, since opposite sides of a parallelogram are also equal, DA is equal to BC. So I can say AR is equal to BC also. So I can say AR is equal to BC since both are equal to DA. Therefore, I can say triangle AQR is congruent to triangle BQC, triangle BQC by BC. So we have taken the two angles, non-infinite sides. So I will tell AAS. So they are congruent by AAS rule of congruency. AAS rule of congruency. Hence, we can say that this we have proved that AQR is congruent to DQC. So I can say that AQ is equal to QB. This AQ is equal to QB, and also CQ is equal to QR. Also CQ is equal to QR by CPC2. So hence proved part 2. Second part has been proved. So okay. So this question number 30, it has been told that through A, B, and C, lines RQ, PR, and QP have been drawn respectively parallel to sides BC, CA, and AB. BC, CA, and AB shown. Is equals to half of QR. That we have to. So here, therefore, it is given that through ABC, through A, B, and C, A, B, and C, lines RQ, PR, and QT have been drawn respectively parallel to the sides, or I can say been drawn respectively parallel to the sides BC, CA, and AB of triangle ABC. Then we have to prove that BC equals to half of QR. So the proof is, here you can see that now RQ is parallel to DC. RQ is parallel to DC. PR is parallel to AC, and QT is parallel to AB. QT is QT is parallel to AB, in triangle PQR, which is given. So therefore, now we can say, now in quadrilateral was ACBR, AC is parallel to RB, and AR is parallel to BC, which is given. Therefore, hence we can say that ACBR is a parallelogram. Since its both pair of opposite sides are parallel. Since it is both pair of opposite sides are parallel to each other. Both pair of opposite sides are parallel to each other. Now, similarly, in quadrilateral, ABCQ, AB is parallel to QC, AB is parallel to QC, and AQ is parallel to BC, AQ is parallel to BC. So I can say that ABCQ is a parallelogram. Is both pair of opposite sides. Both pair of opposite sides are parallel to each. Pair of opposite sides are parallel to each other. Also, we can say in quadrilateral ABCP, AB is parallel to CP, and here the reason I should tell that is given. And AB is parallel to CP, and AC is parallel to BP, is also given. So I can say ABCP is also a parallelogram, since both pair of opposite sides are parallel. Since both pair of its opposite sides are parallel. Pair of its opposite sides are parallel. Okay, so now, so therefore I can say that AB equals to CP. AB equals to CP. Since opposite sides of a parallelogram are equal, since opposite sides of a parallelogram are equal, and also can say that AB equals to CQ. AB equals to CQ. since same reason, since opposite sides of a parallelogram are equal. And also we can say that is AC equals to RB. AC equals to RB, and also AC equals to BP. AC equals to BP. Since they are the same region, since opposite sides of a parallelogram are equal. ABCP we have proved that is a parallelogram, and ABRB ACBR is also a parallelogram that we also have proved. So hence we can see that, so in triangle PQR is this RB equals to BP, which is, since both are equal to AC, RB equals to BP, and QC equals to CP. CQ equals to CP since both are equal to AB. Since these are proved earlier or proved above. So hence I can say that, hence in triangle PQR, B and C are midpoints. B and C are the midpoints of the sides RP and QP, respectively. RP and QP respectively. Therefore, I can say that BC is parallel to QR, and BC is equal to half of QR. BC is equal to half of QR by using the midpoint theorem. So hence proved. Yes, please. So hope that all of you understood the solutions of all these questions till question number 30. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. And please install our Sapience education application also, where we shall upload some important questions which shall be obviously helpful for your exam. So thank you everyone. Bye.